The 2002 National Electrical Code, or NEC, doesn't have a specific section that directly discusses using a 15 amp rated device on a 20 amp circuit. However, it does address the protection of conductors based on their ampacity. Article 210.21b3 of the NEC states that conductors must be protected against overcurrent in accordance with their ampacities, as specified in section 310.15. This principle dictates that a 15 amp rated device should ideally be used on a circuit with an ampacity of 15 amps or less to ensure the device is adequately protected from overcurrent situations. In the context of a kitchen circuit, the NEC mandates that these circuits must be protected by a 20 amp circuit breaker or fuse. Given this requirement, a 15 amp rated ground fault circuit interrupter, or GFCI, wouldn't be suitable for direct use on a standard 20 amp kitchen circuit. This is because the 20 amp circuit could potentially allow more current to flow than the 15 amp ground fault circuit interrupter is designed to handle, potentially leading to overheating or damage to the device. The availability and common use of 15 amp ground fault circuit interrupters over their 20 amp counterparts often raises questions. The key factor is that a 15 amp ground fault circuit interrupter provides an equivalent level of protection against ground faults as a 20 amp ground fault circuit interrupter. Ground fault circuit interrupters are designed to detect very small imbalances in current, typically around 5 milliamps, and trip the circuit to prevent electrical shock. This functionality is independent of the circuit's overall ampacity. The difference between a 15 amp and 20 amp ground fault circuit interrupter primarily lies in their ability to handle sustained overcurrent. A 20 amp ground fault circuit interrupter can handle a continuous load of up to 20 amps without tripping, while a 15 amp ground fault circuit interrupter is limited to 15 amps. For general use in residential settings, where the risk of ground faults is the primary concern, a 15 amp ground fault circuit interrupter offers sufficient protection at a lower cost. However, it's crucial to ensure that the devices connected to the circuit do not draw more than 15 amps in total. To delve deeper into this topic, let's explore several key areas. Firstly, understanding ampacity and overcurrent protection. Secondly, ground fault circuit interrupter functionality. And thirdly, practical application in kitchen circuits. And finally, compliance with NEC regulations. Understanding ampacity and overcurrent protection. Ampacity refers to the maximum amount of electrical current a conductor or device can carry continuously without exceeding its temperature rating. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect conductors and equipment from overloads and short circuits. When the current exceeds the rated ampacity of a conductor, it can overheat, potentially leading to insulation damage, fire hazards, or equipment failure. The NEC provides detailed guidelines for selecting the appropriate size of overcurrent protection devices based on the ampacity of the conductors and the type of load being served. These guidelines ensure that the electrical system is adequately protected from overcurrent situations. Ground fault circuit interrupter functionality. Ground fault circuit interrupters are specialized devices designed to protect against ground faults, which occur when current leaks from a circuit to ground. This can happen when insulation on a wire is damaged, or when a person comes into contact with a live wire and ground. Ground fault circuit interrupters work by monitoring the current flowing through the hot and neutral conductors of a circuit. If there is an imbalance in the current, indicating that some current is leaking to ground, the ground fault circuit interrupter will quickly trip the circuit, cutting off the power and preventing electrical shock. The sensitivity of ground fault circuit interrupters is typically around 5 milliamps, meaning that they can detect even small amounts of current leakage. This makes them highly effective at preventing electrical shock. Practical application in kitchen circuits. Kitchen circuits are typically wired with 12 American wire gauge, or AUG, conductors and protected by a 20 amp circuit breaker. This allows for the use of multiple appliances simultaneously without overloading the circuit. However, the NEC also requires ground fault circuit interrupter protection for all receptacles serving countertop surfaces in kitchens. This is because kitchens are considered wet locations where the risk of electrical shock is higher. To comply with the NEC requirements, a 20 amp rated ground fault circuit interrupter could be used to protect the entire kitchen circuit. However, it is more common to use 15 amp rated ground fault circuit interrupters for individual receptacles or small groups of receptacles. This approach allows for more flexibility in the design of the kitchen electrical system and can be more cost-effective. When using 15 amp rated ground fault circuit interrupters on a 20 amp circuit, it is important to ensure that the total load connected to the ground fault circuit interrupter does not exceed 15 amps. This can be achieved by limiting the number of appliances connected to the ground fault circuit interrupter or by using appliances with lower power consumption. Compliance with NEC regulations. The NEC is a widely adopted code that sets the standard for safe electrical installations. Compliance with the NEC is essential to ensure the safety of people and property. The NEC is updated every 3 years to incorporate new technologies and address emerging safety concerns. Electrical contractors and inspectors are responsible for ensuring that electrical installations comply with the latest edition of the NEC. In summary, while the 2002 NEC does not specifically address using a 15 amp rated device on a 20 amp circuit, it does provide guidelines for overcurrent protection and ground fault circuit interrupter protection. When using 15 amp rated ground fault circuit interrupters on a 20 amp circuit, it is important to ensure that the total load connected to the ground fault circuit interrupter does not exceed 15 amps and that the installation complies with all applicable NEC requirements. The use of 15 amp ground fault circuit interrupters on 20 amp kitchen circuits is a common practice that provides adequate protection against ground faults. However, it is essential to understand the limitations of this approach and to ensure that the electrical system is properly designed and installed to meet the specific needs of the application. Let's expand on several more key points regarding this. Firstly, NEC requirements for kitchen circuits. Secondly, understanding device ratings and circuit protection. And thirdly, practical considerations for ground fault circuit interrupter selection. NEC requirements for kitchen circuits. The NEC has specific requirements for kitchen circuits to ensure safety due to the increased risk of electrical shock in wet environments. Section 210.11 CON typically requires at least two 20 amp small appliance branch circuits to serve all receptacle outlets on the countertop in the kitchen. These circuits are intended to supply power to countertop appliances such as toasters, coffee makers, and blenders. The purpose of having dedicated small appliance circuits is to prevent overloading the general lighting and receptacle circuits, which could lead to nuisance tripping of the circuit breaker or even a fire hazard. Additionally, Section 210.86 typically requires ground fault circuit interrupter protection for all 125 volt, 15 and 20 amp receptacles serving countertop surfaces in kitchens. This requirement is designed to protect people from electrical shock hazards that can occur when using electrical appliances near water. The ground fault circuit interrupter detects small imbalances in current and quickly shuts off the power to the receptacle, preventing a potentially fatal shock. Understanding device ratings and circuit protection. Electrical devices are rated for both voltage and amperage. The voltage rating indicates the maximum voltage that the device can safely handle, while the amperage rating indicates the maximum current that the device can continuously carry without overheating or being damaged. Circuit breakers and fuses are designed to protect circuits from overcurrent conditions. When the current in a circuit exceeds the rating of the circuit breaker or fuse, the device will trip, interrupting the flow of electricity and preventing damage to the wiring and connected devices. It's important to select the appropriate size circuit breaker or fuse for a circuit based on the ampacity of the conductors and the type of load being served. Oversizing the circuit breaker or fuse can lead to a false sense of security and can actually increase the risk of fire. Practical considerations for ground fault circuit interrupter selection. When selecting a ground fault circuit interrupter for a kitchen circuit, it's important to consider the specific needs of the application. For example, if the circuit is only serving a single receptacle, a 15 amp ground fault circuit interrupter may be sufficient. However, if the circuit is serving multiple receptacles or if high wattage appliances are being used, a 20 amp ground fault circuit interrupter may be necessary. It's also important to consider the type of ground fault circuit interrupter being used. There are two main types of ground fault circuit interrupters: receptacle type ground fault circuit interrupters and circuit breaker type ground fault circuit interrupters. Receptacle-type ground fault circuit interrupters are installed in place of standard receptacles and provide ground fault protection only for the specific receptacle. Circuit breaker-type ground fault circuit interrupters are installed in the electrical panel and provide ground fault protection for the entire circuit. The choice between receptacle-type and circuit breaker-type ground fault circuit interrupters depends on the specific needs of the application and the overall design of the electrical system. Additionally, it is important to ensure that the ground fault circuit interrupter is properly installed and tested to ensure that it is functioning correctly. Ground fault circuit interrupters should be tested monthly by pressing the test button on the device. If the ground fault circuit interrupter does not trip when the test button is pressed, it should be replaced immediately. Now let's talk about some specific cases to provide clarification. Firstly, general-purpose receptacle circuits. Secondly, dedicated appliance circuits. And thirdly, multi-wire branch circuits. General-purpose receptacle circuits. General-purpose receptacle circuits are typically used to supply power to a variety of electrical devices such as lamps, televisions, and computers. These circuits are usually wired with 12 American wire gauge or 14 American wire gauge conductors and protected by a 15 amp or 20 amp circuit breaker. When using a 15 amp rated device, such as a standard receptacle, on a 20 amp general purpose receptacle circuit, it's important to ensure that the total load connected to the circuit does not exceed 15 amps. This can be achieved by limiting the number of devices plugged into the circuit or by using devices with low power consumption. It's also important to avoid using extension cords or power strips, as these can overload the circuit and create a fire hazard. Dedicated appliance circuits. Dedicated appliance circuits are used to supply power to specific appliances, such as refrigerators, dishwashers, and washing machines. These circuits are typically wired with 12 American wire gauge conductors and protected by a 20 amp circuit breaker. When using a 15 amp rated device on a 20 amp dedicated appliance circuit, it's important to ensure that the appliance does not draw more than 15 amps. This information is usually provided on the appliance's nameplate. If the appliance draws more than 15 amps, it should be connected to a dedicated 20 amp circuit. Multi-wire branch circuits. Multi-wire branch circuits are a type of electrical circuit that uses a shared neutral conductor to supply power to two or more circuits. These circuits are typically used in kitchens and bathrooms to provide power to multiple receptacles and lighting fixtures. When using a 15 amp rated device on a 20 amp multi-wire branch circuit, it's important to ensure that the total load connected to each leg of the circuit does not exceed 15 amps. This can be achieved by carefully balancing the load between the two legs of the circuit. It's also important to use a double-pole circuit breaker to protect the multi-wire branch circuit. A double-pole circuit breaker will trip both legs of the circuit simultaneously, preventing a potentially dangerous imbalance in the neutral conductor. Finally, let's discuss safe electrical practices and the importance of consulting a qualified electrician. Safe electrical practices working with electricity can be dangerous, so it's important to follow safe electrical practices at all times. Firstly, always turn off the power to a circuit before working on it. Secondly, use insulated tools when working with electricity. Thirdly, never work on electrical equipment when you are wet or standing in water. Fourthly, inspect electrical cords and plugs for damage before using them. Fifthly, replace damaged cords and plugs immediately. Sixthly, never overload electrical circuits. Seventhly, use ground fault circuit interrupters in wet locations. Eighthly, have your electrical system inspected regularly by a qualified electrician. The importance of consulting a qualified electrician. If you are not comfortable working with electricity, it's always best to consult a qualified electrician. A qualified electrician has the knowledge and experience to safely install and repair electrical systems. They can also help you to ensure that your electrical system complies with all applicable codes and regulations. Hiring a qualified electrician is an investment in your safety and the safety of your property. In conclusion, the use of 15 amp rated devices on 20 amp circuits is a complex issue that requires careful consideration of the NEC requirements, device ratings, and practical considerations. While it is possible to use 15 amp rated devices on 20 amp circuits in certain situations, it's important to ensure that the total load connected to the circuit does not exceed 15 amps and that the installation complies with all applicable codes and regulations. If you have any doubts or concerns, it's always best to consult a qualified electrician.